Hello everybody, I'm Roman Rodriguez and we are on chapter 4, Motion and Force, and we are on the topic of motion of bodies connected by a string passing over a frictionless pulley. There are two cases to it. This is lesson 4a, where we will be discussing about when two bodies they move vertically, one moving up and the other moving down. The second case will be a body moving horizontally and the other body moving vertically downwards. So, excuse me. So, if you look at this diagram, we have two bodies suspended over here by means of this pulley, and this body B is moving upward and body A is moving downwards. Okay. So, if you look over here in this case, the tension is less than the weight. In other words, the weight is greater than the tension. Okay. Let's say we call this body A as 1, so W1 is greater than tension. And over here for the body moving upward, the tension is greater than its weight. In other words, T is greater than W2. Okay, so let us consider the two cases, and for one body moving upward and the other moving downward, we need to prove that the acceleration in this case is equals to m1 minus m2 upon m1 plus m2 times g. G is acceleration due to gravity, and T, the tension, is equals to 2 times m1 m2 upon m1 plus m2 g. We'll be proving this now. So let's say consider this body A moving downwards. Okay, so for body moving downward, as you know that the weight W1 is greater than tension T. So W1 is greater than T. So the total net force acting on it will be F1 is equals to W1 minus T. Okay. Now, according to Newton's second law of motion, okay, F is equals to ma. So I can write this down as M1A is equals to W1. You know, W is equals to mg. So this can be replaced by M1g minus T. Okay, so let's call this equation 1. Now, for body moving upward, let me put it down over here, body moving upward, we know that the tension is greater than the weight, W2 in this case. So, tension is greater than W2. So the total net force will be T minus W2 is equals to F. And since we are talking about 2 second weight, so we'll write it. And according to Newton's second law of motion, F is equals to ma. So I can replace F with ma. We are talking about mass 2, and tension minus W2 as mg. In this case, it is. Let's call this equation number 2. Now, when I add these two equations, 1 and 2, what do I get? I get m1a plus m2a equals to m1g minus t plus t minus m2g. This is when I add equation 1 and 2. So, taking A acceleration common, I'll get m1 plus m2 is equals to t minus t and plus t will cancel. Over here, if I take g common, I'll get m1 minus m2 times g. Or if I move this over here on the other side, I'll get acceleration is equals to m1 minus m2 upon m1 plus m2 g. There you are. We've just proved the acceleration is equals to m1 minus m2 over m1 plus m2 times g. Okay. Now, in order to know the tension, this cable or string, what do? We substitute the value of A in any one of these equations. Let's say we substitute in equation number 1. So equation number 1 will now be m1 times, instead of acceleration, I'm going to put its value, that is m1 minus m2 upon m1 plus m2 times g is equals to m1g minus t. Now, all I need to do is, I need to bring tension on the other side and this whole thing on the other side. Okay, I'll just keep, so this will now become, let me do it over here. I think there is space over here to do this. M1 into M1 minus M2 over M1 plus M2 times G. If I bring this on the other side, I'll get minus M1G is equals to minus T. Okay? Or I can write this equation down as tension is equals to M1G, and this whole thing will be minus M1 into M1 minus M2 upon M1 plus M2G. So taking M1 plus M2 as your LCM, M1 plus M2, I now get M1 times M1 plus M2 G minus M1 into M1 minus M2 G. Just cramped up for space. There you go. So let's expand this bracket, or what I could do is I could take M1G common, and then I will get M1 plus M2 minus M1 minus M2 over M1 plus M2. So this tension will now be M1G. Let's expand this. M1 plus M2 minus M1 minus and minus plus M2. So you can see that plus M1 minus M1 will cancel over M1 plus M2. So hence tension is equals to M2 plus M2 would give you 2M2. So I have 2 M1 M2 over M1 plus M2 the whole times G. There you go. So we have just proved the tension is equals to 2 times the product of mass M1 M2 over the sum of mass M1 plus M2 within G. So I hope it is clear to you all. So I'll be doing the next case, that is when body is moving horizontally. One moving horizontally, the other moving vertically. Hope to see you then. Take care. God bless.